Hello, I'm Dr. Roberts from Intro to Electrical Computer Engineering at UTEP, Fall 2021, and we are looking at the Week 10 practice problem number 6 in this video. And if you've been following along in the previous practice problem number 5, we did a non-inverting amplifier. This practice problem does another op-amp circuit, but you'll notice now the input is connected to the negative or inverting input versus the previous one was connected to the positive non-inverting input in a slightly different manner. However, we're going to use the exact same method to solve. And so one thing, okay, if we look at this, and we'll show it in a minute, what type of amplifier is this? Well, it says this is connected to two resistors to the inverting negative input. This is an inverting amplifier, and we'll see that. And it will have a gain equation, and then we can plug that in. But to do this, let's calculate. Now, as we did with the previous problem, right, we know a few things, right? We know by definition for ideal op amp that the inverting input voltage V sub n has to be equal to V sub p. And we know that the current going into the inverting input I sub n is equal to 0, and the current there in the positive is equal to 0. So we see here we have ground. Well, that's equal to V sub p, which is equal to V sub n. And V sub n is equal to V sub a here, is equal to V sub a. So what we know is that V sub a is equal to 0 volts, taking advantage of this. Now we can draw some currents. Let's see here. We can call this I1, and we'll call this I2. And we can leave then IN on here. We can now do KCL at A. And if we do that, we get that what? I1's going in, so it's going to be equal to positive plus I2 minus IN is equal to 0. This is 0 by definition, so it goes away. And we get, if we move it around, the I1 is equal to negative I2. Right? Which you see there's this negative here compared to the previous problem with positive. Now again, we can use Ohm's law, right? Where I is equal to V top minus V bottom over R for each of these currents, and we can do that. So for I1, and if you don't want explanation on this, go back to problem 5 and the video and I explain it. So then if we use Ohm's law here, we can write it in terms of current. So I1 is going to be equal to Vn minus Va over R1. Then we know Va is equal to 0, so that's just going to be equal to Vn over R1. Similar now we can find for I2, and that's going to equal to V out minus 0, or V out minus VA over R2, where we know VA again is 0, so that's going to be equal to V out over R2. And just like in the previous problem, then now that we have an expression for I1, I2, we can substitute these in and solve. So if we do that, and I'm going to maybe write it over here this time, right? So I don't run, I'm running on the column is what I like to do when I do this. So here we get that I1 can be written as Vn over R1 equal to negative I2. So negative, then I2 is equal to V out over R2. And now we can rearrange, right? So let's multiply negative R2 across, and we can divide through then Vn. So then we get that, well, I can do it in a couple steps here, right? So that's equal to minus R2 over R1. Vn is equal to V out. Then we can divide this across. We get that negative R2 over R1 is equal to V out over Vn, or that V out over Vn is equal to negative R2 over R1. Right? Simple gain, right? It's just the ratio of these, the feedback resistor here. You'll see R2 is often written as RF, and R1 is written as Rin. But it's just the ratio always in this for this format. So here's the gain, and we can see it inverts. This is an inverting amplifier. Now in part B, then if we want to calculate, we can plug it in. Right, so then if we get that, so if R2 is equal to 10 kilo ohms, R1 is equal to 5 kilo ohms, then V out over V in is equal to negative 10,000 divided by 5,000. Those will cancel. So that's equal to minus 2 is the gain on that particular resistor. So that is a basic inverting op-amp circuit. And what you'll see then is always the gain for the circuit will always be negative whatever equivalent resistance or equivalent impedance in the feedback is. It could be multiple things, divided by whatever the equivalent impedance is to the input, right? It's always this ratio. And in the next problem, we'll see what happens if we make a slightly different, more complex circuit, right? So if I put two resistors here, what happens? So let's try it. I'll see you in practice problem 7.